Download this code from codegive.com, link in the description below. Certainly. While I don't have direct access to specific episodes of a show or tutorial series, I can help you conceptualize what an episode 7 of an inventory management system could look like, focusing on debugging techniques and improvements to the system. Episode 7, Debugging the Inventory Management System. In this episode, we'll focus on identifying common bugs in our inventory management system and implementing debugging techniques to resolve these issues. We'll also discuss best practices for maintaining a robust system. Common issues in inventory management systems. 1. Incorrect inventory counts. Items may be overcounted or undercounted due to improper handling of stock levels. 2. Concurrency issues. Multiple users might update the inventory simultaneously, leading to race conditions. 3. User input validation. Poor input validation can lead to incorrect entries in the inventory database. 4. Data integrity. Relationships between products, suppliers, and orders may become inconsistent. Debugging techniques. 1. Logging. Implement detailed logging to capture the flow of data and any errors that occur. 2. Unit tests. Write unit tests for critical functions to ensure they behave as expected. 3. Step through debugging. Use a debugger to walk through your code line by line to observe where things go wrong. 4. Error handling. Implement try-catch blocks to gracefully handle exceptions and log errors. Code example. Let's say we have a simple inventory management class in Python. We will debug a method that updates the inventory count of a product. Python. Class inventory. Def__init__, self. Self.stock equals. Def add_product, self, product_id, quantity. If product_id in self.stock. Self.stock product_id plus equals quantity. Else. Self.stock product_id equals quantity. Def update_product_quantity, self, product_id, quantity. If product_id not in self.stock. Raise value error, F product ID not found in inventory. Debugging, log the current stock before updating. Print, F current stock for product_id, self.stock product_id. If self.stock product_id plus quantity 0. Raise value error, insufficient stock to complete this operation. Self.stock product_id plus equals quantity. Debugging, log the updated stock. Print, F updated stock for product_id, self.stock product_id. Example usage. Inventory equals inventory. Inventory.add_product, A101, 50. Try. Inventory.update_product_quantity, A101, -60, this should raise an error. Accept value error as E. Print, F error, E. Try. Inventory.update_product_quantity, A102, 10, this should raise an error. Accept value error as E. Print, F error, E. Explanation of the code. 1. Initialization. The inventory class initializes an empty dictionary to hold product IDs and their respective quantities. 2. Adding products. The add_product method allows adding new products or updating existing ones. 3. Updating quantity. The update_product_quantity method checks for the existence of the product and whether the update would lead to negative stock. It also includes debugging print statements to log the stock before and after the update. 4. Error handling. The method raises value error exceptions for invalid operations, which can be caught and logged. Best practices. Input validation, always validate user inputs to prevent invalid data from being processed. Concurrency control, implement locking mechanisms or use database transactions to prevent race conditions. Regular testing, continuously write and run tests for new features and bug fixes. Documentation, document your code and any debugging steps taken for future reference and maintenance. Conclusion. In this episode, we focused on debugging, a critical part of the inventory management system. By implementing logging, error handling, and following best practices, we can create a more reliable and maintainable inventory system. In future episodes, we might explore enhancements like user interfaces, reporting features, or integration with e-commerce platforms. Stay tuned.